Hello, how's it going, YouTube? This is Bryant Interviews, and I have a very personal good friend, Alejandro Baez, with me today. And today, we're going to talk about his work as a site reliability engineer, possibly go into technology, AI, and all that fun stuff. But let's start with the basics. After doing a bunch of research, it's actually something that is very hand in hand with DevOps. Like site reliability engineer started with DevOps, then Google created their own team. Is that correct? Something like that?
Yeah.
Correct me if I'm wrong.
So yeah, so the idea was that we would have essentially a role to define a sort of set of practices over how to keep a platform or a site afloat, right? So the idea is that you have a software developer and operations engineer, aka DevOps, that would formulate a concept for you to use throughout your whole company. And then the the actual role for that concept ends up being this site reliability engineer. So
So
yeah, it's a little give and take over
I,
it.
I hear the holy grail is five nines or 99.999% uptime.
Yeah. So the idea is that um you have different sites that are available, or different companies essentially that have this vital necessity to always be accessible to all the clients or consumers that they have inside their platform, right? So the issue is that a lot of people end up having a very large constraint over how 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 short they can have a time span between when their site is up and when it's not. And the idea is that the five nines is to actually give a very low minimum amount of time where your site is only down for a couple seconds each month. And that's the idea.
I mean, I can imagine that, if, especially like if it's law enforcement, healthcare, or something that, or military, or Facebook, or Gmail,
Right.
Zoom, even, that you want to have that reliability. And one of the important things that I read that a site reliability engineer does is they automate their processes, and then they focus on being able to scale up the site's operation. Is that correct?
Yeah, that's completely correct. So
So,
yeah,
mhm.
so one of the very key parts of this is exactly that. It's being able to actually factor out the human part of keeping a platform reliable. So site reliability engineer has this necessity or requirement, and so to speak, to actually make sure that an entire company stay afloat and stay afloat as efficient as possible. So technically speaking, if you get to the point where you have your company that is completely automated, where your position is not needed anymore, that's actually your goal. So that's what you're trying to achieve. It doesn't necessarily mean you're ever going to reach it, but it ends up being the goal that you're trying to accomplish in this
That,
type of
that's
position.
actually a very important concept, which is the concept of technology and automation. So like we see like a growing trend nowadays, like even restaurants, I see like there's a miso robotics, and they're like, okay, here's a robot that helps cook and put food in the fryer. And it seems like the general trend is that technology, especially what site automators do, is that they want to be able to remove as many humans as possible from doing the work, because computers are more reliable, or how what's the thought process?
So the idea is that what we're trying to do here is not necessarily remove humans from the process, but remove the largest factor of error, which is
Okay.
humans. So so a lot of problems that come in with when it comes to platforms, when it comes to on-site development, when it comes to pretty much almost every technological field or hard science field, it ends up having to be that it's the human that is the one that does the errors, because it makes sense, we're human, to human
Right.
is to err, right? But there are some caveats to this, is that what you really want to do is not necessarily remove the human, but to make the human more accessible to not make errors. So you leave computers to do what they do best, which is computational intensive actual work with fact checking practically everything. And the idea is that as long as you go ahead and build out your full framework of being able to utilize some automation tooling or whatever, you end up having a case where you can leverage more of what your specialty relies on without having to actually um, do those manual labor tasks that would be error prone.
That's actually interesting because it brings me to the idea of like my introduction to computers is the advent of copy and paste. Like instead of having to
Right.
type out an entire 10-page essay over and over again, I can just save and make multiple copies. So I feel like technology's role has been to make it easier to do tasks without error over and over again. Is that my understanding?
Yeah, yeah. That's the complete idea when it comes to technology, or when it just comes to computing in general, or
So
even all of our engineering now. It's the process of automation. It's the process to alleviate the stress of having to do these repetitive tasks.
do you feel like that frees you up into being able to think more creatively about solutions and being able like how does that affect your ability to be more productive, having a computer be able to take over these tasks that might be mundane or repetitive?
Yeah, yeah. That's actually a very good question. So one of my very key aspects anytime that I start a new role in any company that I'm working under, I end up looking at what we can do to essentially first remove the human, as I said, but then second, to actually start building pieces that make that platform stellar, make it beyond what it can normally be achievable if it was dealt with manual tasks. So
So
when you get to a point where you're automating that actual framework, you end up being in a case where you have an entire landscape that you're able to build from. And that landscape ends up actually allowing you to start architecting different parts of a company in a way that you normally wouldn't be able to if you didn't have this automation. So yeah, it totally frees up your creativity, so to speak, to be able to start thinking on how to actually make a company perform better, how to actually change it in a way that is better sustainable to its current goals.
that's actually interesting because like technology as it's evolved, like before we had video cameras, there was no such thing as movies or film.
Right.
So basically camera was invented and you have a whole genre invented. So what has in your field invented that has allowed something new to occur? Like what would be an example of that?
So from my field, I think the piece that would actually play the biggest role right now has been um infrastructure as code, is is defining entire entire design on how you architect different software together in a way that is programmatically defined. So you can do full testing and automation before you even actually deploy a change. You can go ahead and start structuring your platform, so to speak, in a way that it doesn't necessarily require manual tasks to actually verify if it's functioning or not. You can actually define it programmatically. And part of this is the whole shift with using a software orchestrator called Kubernetes, which allows us to actually start building our entire cloud as a programmatically defined construct that's standard across every company provider that exists. And this allows us to start building software and tooling that basically elevate our true requirements when it comes to companies. And it's basically the business logic, what actually makes the money.
So there's also a curiosity in terms of limitations, and computers and technology, they still follow the rules of math and physics as far as
Right.
I'm aware. So like with things like scaling up, we see a lot of nowadays, like we have cloud services like Dropbox, Google Stadia, Amazon Alexa, and all these cloud services nowadays. How does the site reliability engineer account for how those cloud services have to scale, and what kind of physical limitations do you have to think about when you?
Yeah, that's actually a very good question. So I recently had a conversation with our executives inside my company, where we're trying to essentially figure out what would be the bottlenecks when it comes to the scale and proportion as our company grows and its current landscape. And we're hitting a point where we're literally hitting limits over physical necessities, over physical design of the architecture, to the point that you end up actually having to think on how long of a latency you have between two different regions in the planet, because the latency actually plays a very vital role in just the performance of the actual site. Or like the difficulties when you have just your services connected globally. You have to start thinking of how you're able to actually keep that connection consistently without actually it being looked like you're actually loading. So for example, in google.com right now, when anytime that you hit google.com is actually a geolocated site. It's technically speaking like thousands of different versions of google.com are running continuously in different
Wow.
regions, in different locations, all essentially co-allocated to the location that you're in.
Wow.
So what we do is we build the structure that makes it look seamless. So where you're having a case where let's say an entire eastern region of the United States is down, you actually perceptibly might only see a couple of milliseconds of difference between the capacity of what you had on Google versus what is normally the case. And the reason is due to that seamless transition of being able to define that geolocation necessity. This is just called geolocation redundancy of disaster recovery.
So that's actually interesting, because it's like depending on how close something is the faster you can commute between 2 points, correct?
Right. Just simple physics.
Right.
Yeah.
So that actually makes it interesting, because you actually have somewhat of a background in physics yourself. How
Right.
has physics influenced your thinking as an engineer, when you're coding? When people think about coding, you can learn coding like hello world, and you can type a simple string and then hello world pops out. But then you have to think about things in the physical world, like bottlenecks, like you were mentioning.
Right.
Like I can imagine if I have to send a signal to around the world, light has a physical limitation of traveling around the earth 7.5 times a second, or
Right.
so I'm told. How do you use your background in physics, your understanding of physics, to make it a better system?
Yeah, that's actually a very good question. So, one piece when it comes to my physics background, is that I've used the capacity of what I learned in academia to basically engulf like what I do. So what I mean is that I use the tool set that I've been given and being able to critically think over a problem and being able to actually formulate a question for an answer that we might not yet know of. And this ends up playing a very strong factor in how I essentially design and architect a lot of the infrastructure that I build for companies. Is that I take a very I take the scientific method very religiously when I'm building out the architecture, and I start trying to think of what would be the literal limits that we're actually able to actually function with whatever we have. So whether that would be you have a certain level of constraint simply because of how you design your algorithms that end up actually slowing down the capacity that you're able to handle, whether that's bottlenecks over how you define your databases that end up actually crippling your company. There's multiple different factors of this, but all of this falls into physics. So you end up in a case that you start thinking of problems on what are their actual limits in their design for the algorithms, and then how can we build around those limits. And this is even plays even a larger role when it comes to like a company as large as AWS, which is just Amazon Web Services, right? In AWS, they provide you with essentially a cloud definition of different resources that you can use. And each one of these resources have a very specific limit of what they can do. And what your job as an engineer is to actually use those limitations to their fullest, is to be able to actually try or even achieve and hitting those limits constantly. And the reason why I say this is that you want to be able to start designing your software in a way that allows you to use the full capacity of what you're currently using. And so it gives you a way to actually start building software that is able to actually achieve further than what normally would be the case. And this just comes down to thinking of the physical limits.
So that's actually a good, like, so we always have the physical limits and how you communicate through machine language. And when you're making code or you're developing these programs or systems, how important is it that you're designing it for efficiency? How important is it that you have to make it organized? Because I would assume that you also have to work with other people because there's a
Right.
human body limitation as well.
Right. Right. So when you're doing this, your biggest goal is, again, to make it so that way you remove the human factor inside the human part of your software development. So a lot of a lot of a lot of work goes into battle testing your own code, is as in
What do you mean by
um
battle testing?
so what I mean by battle testing is like you add documentation, you add unit tests, you add integration tests, you make it in such a way that has a specific standard, a standard that is usable by anyone else that would actually come in. Let's say for whatever reason you hit the lottery, right? And you're like, bye guys, I'm not gonna work here anymore. Well, one of the key parts of that is that you want to make it so that way when you leave, the software that you built is well documented, has all these actual tests built in, that another person can come in and read it and be able to pick up exactly where you left off. And that's the very key part of this, is um you have to be able, when every time that I've been saying that you need to architect your software, you need to architect your software. you can't you can't just simply just start writing code and then expect it to just flow. You can, but what you end up having is a very large point of cold smell, so to speak. It's a way that you end up having problems later on due to your original design. And it ends up creeping up and becoming a larger and larger issue, which eventually ends up being called your legacy. And you end up having to actually work with your legacy to be able to actually build. So when I said about the algorithms that you design to actually go ahead and build stronger architecture, you need to be able to first think of what are your limits over what you're using, and then build backwards. So that way, when you're building your architecture, when you're building the design for your software, the data models that you use will be based on this literal limit that you're able to hold. So doesn't mean that you will get it right every time, or that you will get it wrong every time, but it means that you have a limit that allows you to lessen the strain of just bad design when it comes to your software. And again, it's your architecture. The better that you do it, the better time that you take over trying to design your architecture correctly, the better that you have your software and, so to speak, your business.
So when people start to design software, and when people are starting to learn to code, they typically think Python, C++, Java, and they're basically dabbling in these languages. Someone in your capacity, having had to gone through many different languages and seeing how they work, how important is it that people develop a sort of plasticity or an ability to understand the overall concept of what the languages do, so that they can shift around different languages as needed versus stay rigid to one specific language alone, like only operating in Python?
So that's actually a very good question. So this comes more with not necessarily the language, but with the paradigms of programming that you want to know. So what I mean is that you want to be able to actually adapt to change. And if you're not able to adapt to change, you end up being limited by the actual language that you know. So what I mean is that you can learn just one programming language, but you can also have an understanding of multiple paradigms of programming languages. So this allows you to think of a problem quite differently every time when you're trying to solve a problem. What I mean is that, let's say if you have an issue with that requires a very fast response time, a very computationally inexpensive order of action, right? Well, what you end up having to do is you end up thinking of ways that you can use algorithms that would be more attributed to faster actual operations with less complexity. So you end up thinking of how to actually solve issues without using, like, let's say, object-oriented design, because you're trying to think of structures that can move as fast as humanly possible. Well, fast as computationally possible. And you keep going in these routes, but it's due to the paradigms that you actually learn. So me personally, I have learned quite a number of languages. I know 15 so far, and I'm still learning more. But the reason is that I've used the languages as a way to learn the paradigms, is to learn the concepts of what I'm trying to actually achieve. So whether that's procedural programming language, whether that's object oriented, functional, and imperative. The list goes on. It has to do with how you think of a problem and then how you solve it. So you've heard me many times before say this, is that it doesn't necessarily matter the language that you know, it just matters the focus that you're trying to put on a language. So if you're trying to do a lot of data science work, there's been a lot of already legacy design for machine learning in Python, for example. So it would be a very lucrative place to actually uphold, because you'll be able to inherit a lot of the mind share of algorithms that people have done in Python to be able to use the machine learning in a better and sustainable way for you, whether instead of having to do that, let's say in C or C++, because the frameworks that you have are more orchestrated for that specific use case. And this goes further into all the rest of the programming languages, is while many of them try to become general programming languages, which means that they are able to do every single task that you're able to throw at them, what you should be thinking of is not them as general programming languages, but as specific domain languages that just happen to be general, that you just can use for other pieces. But maybe you shouldn't. Maybe you should actually think of using the right tool for the right job.
That's actually interesting in terms of like different languages, like you knowing what tool to use. So we like the computer you used 30 years ago, 20 years ago is not the same computer we use today.
Exactly.
So how important is it that people also like it gives me the idea that learning itself has to be a skill that is learned, so to speak. Like you have to learn how to learn or you have to learn how to be able to adapt to new languages, and that in itself seems to be a skill because technology seems to be ever changing so quickly.
Yeah.
How do you view that? What are your views
No.
on that?
Yeah, that's actually very true. So I'm a very hard believer in self-learning, simply because that's how I've entirely built my career. But not just that, I think that being able to actually learn, you need to take the time to adapt into learning and to actually finding it enjoyable. It needs to be part of like a essential necessity that you have, because especially when it comes to technology, you end up getting in a place that you have a very hard requirement over how much you're able to actually absorb constantly. And for example, in my role, I am 90% of my time just studying. The 10% that I spend on my day is actually solving problems. The rest of the time is me learning of different ways to solve problems. So this is a very important part of what you actually do as a software developer, and what you do and just in general is you need to be able to take the time to learn and learn how to learn for yourself, so you can actually start grasping different ideas, different paradigms that are usually uncomfortable, and you end up absorbing different ways to actually solve problems. So if you keep doing that, you end up being able to actually solve problems faster. Because the whole goal here is to solve problems. We're not necessarily doing something different, whether that's SRE as a site reliability engineer, a software developer, electrical engineer, mechanical engineer, the list goes on. You're solving a problem. You're trying to, you're given a set of issues, and you're trying to make a solution to those issues. And the way that you get to a better solution is by being able to continuously learn of that solution, is being able to think of different ways to actually get to the answer.
How important is it to have a curiosity of how things can be done differently, or a sort of imagination, so to speak, in your field?
I think it's extremely important because in my field, you end up in a place where you're never going to have the same exact problem every time. You might have similar problems constantly, but they won't be the same exact problem. It would be just slightly different. You would have just a slight different change of variables, which just ends up either blowing up your entire 3-4 weeks of labor, or it ends up just taking you a few minutes to resolve, even though it looks as a similar problem. And the reason is that you end up having cases where the unknowns are truly unknown, and you have to be able to actually think of different solutions to an unknown that might be similar to what you did before. So being able to actually think of different avenues on how to actually solve that particular problem is vital, because you end up with cases, as I said, that are not necessarily just black and white. You end up in cases where you do have to think of different solutions to even just get to the correct, to any solution, not even just a correct solution. So that creativity of being able to actually think in different ways is very vital. And like, I think this plays more into people that have played video games or like playing chess or play checkers or whatever. Is it ends up in a case that you learn how to adapt to learning. You end up thinking of how to solve different problems in different ways. And like, even like when you play like a game to like speed run, and you're trying to actually think of how quickly can you actually pass level 1 to level 2, right? Or level 1 to end game. You're trying to you're looking at different ways to actually bend the limits of what your constraints are.
Mm.
And as in doing so, you're thinking of different avenues on how to better perform, how to think of how you can jump just slightly smaller to be able to get to that hill slightly faster. Like, these are pieces that are very important when you're actually doing the work that I do, because you need to have a way that you can actually morph those limitations that you might normally have, and set boundaries on your actual on your actual problem solving. So as long as you're able to adapt to different solutions, but still be able to think of different answers to a single solution, you're able to start formulating different ways to resolve issues, and you end up having an easier time simply because you took the time to
Mm.
actually learn from those problems.
So in terms of learning, I noticed that like back in before, you used to play football, you used to run track, and those things test the physical limitation of the body, how fast you can run,
Right.
like how much you can take a hit. And nowadays, especially what you're doing, do you feel like this kind of mental workout, doing what you're doing, exercising the creative muscle, is a sort of mental athleticism that you have to work on and develop as well? Or is it just something that, oh, you just have it?
No, I think you're absolutely right. I think it is something that it's like a mental athleticism. Like, you have to be in a place where you're constantly trying to strive for something. So you're absolutely right that this does fall into my natural athletic adaptation when I was younger. but it also has to do with just simply trying you're trying to still work that muscle that you have in your head, right? It's still a muscle, and you still have to keep using that muscle if you want to actually do achieve great things, right? So uh, part of that is that your brain, as this muscle, has to constantly learn. It's a machine that actually never stops learning. And the moment that you stop learning, the moment that you have something that feels repetitive, is the moment that you've gone enough in doing that problem, and you should start trying to look at different solutions, different issues, different ways, different um difficulties for a problem. Anything that becomes repetitive needs adaptation for you to actually go further. So this is part, I think, of when it comes to learning. You need a way to know that repetition helps, but also limits you. You become comfortable with that repetition.
Mm.
So you want to be able to keep growing that capacity that you have. As of right now, we don't know the actual physical limit of our brain. We do know that we have a limit, but we haven't necessarily reached a point that you can say like, oh, you learned X amount in your life. That's it. You cannot learn anymore. That's just not true.
Mm.
It just means that it takes you longer if you learned quite a number of tasks in your lifetime. But it
How
doesn't
does
mean that you stop. Yeah.
how does human learning compare with this new field of machine learning?
So they're vastly different. So machine learning, you can think of it as a very fancy if statement. It's
Mm.
either it's saying yes or no in a very fancy way.
Mm.
The human mind works works in a way that we still don't understand. It has its entire. All right, so let me give a better example. So in my job, I spent um a good deal of my time orchestrating what's called an orchestrator, right? Which, whether it be HashiCorp Nomad, whether it be Kubernetes or whatever, um, an orchestrator's job is to orchestrate jobs.
Right.
It's very simple task. But it does in a way that it uses multiple computers. So it uses multiple different computers to achieve a specific goal, whether that's reliability in multiple different regions in the planet, or whether that's just keeping your site available inside one location in one place inside your home.
Mm.
Um, the piece here is that the orchestrator's job is to keep that communication between all the different intrinsities that make that orchestrator function. So an orchestrator has just countless of different moving parts, moving different machines that come up and down, and they change different variables and stuff like that. Inside the human brain, we have the neurons, right? Which
Right.
everyone practically knows. If you don't, you should. And the neurons are chemically bound to one another, in that they send a signal to each other, and they're relatively dumb in their capacity. They're only able to send a couple signals to another neuron, and then that's it. But with that small capacity, now what we have is a way to actually define definitively over what would be a certain action to a certain condition. And as we keep as you keep growing that set of neurons, you end up having a larger capacity of what you can do. So our brains have a very large quantity of it's in the billions easily. And the reason is that while they're all dumb individually, collectively they essentially bring up the capacity of what you
Mm,
have as your brain. So going back to the original point here is that your brain has countless of different firings of multiple different networks all the time. In fact, as I'm speaking,
right.
I'm doing a formulation of countless of different connections all the time. And inside a machine learning algorithm is nowhere near this. It's not even close to the capacity of doing this.
Mm,
It's as if we were trying to define a single neuron
mm,
inside a machine learning algorithm. That's
wow.
what we do here. We're defining a single neuron. We're not defining the entire brain. So a machine learning algorithm, its capacity is limited by the constraints that we've designed them for. They're not they're not built smart. But that doesn't mean that we can't do very
Mm,
fancy things with them. So if you bring one of the very interesting parts of machine learning is that it's it's only it's only usable at scale. It's
mm,
not really usable at a very small capacity. Like you shouldn't try to run a full data model inside your laptop or your phone, for example. You'll get something, sure, but it's not gonna be as conclusive as let's say an entire data center's level
mm,
of capacity. And the reason is that remember that I said that they're just very fancy if statements.
right.
Well, the fancy if statement is capable of doing relations the larger of a data set that it's
Mm,
able to compute with. So the more data that has, the better it is to be able to do these relationships. And that's all it does. Now, we don't necessarily have a model of, and well, not model, an algorithm in machine learning that would allow us to go ahead and build um a human brain, for example.
right.
What we do have is the capacity to do single neuron interactions and
Wow.
use that to be able to formulate at scale better contrived answers.
That's actually very interesting because when I think about optimization or creativity or like for example, if you play a game of Connect Four, there is a guaranteed solution to victory if you go first. Like if you play a
Right,
certain way, you are absolutely 100% of the time. If you follow this method, will always win. And I feel like that sort like machines might be playing that game in like a formulaic way. They play it based on a formula, based on an equation, but then human beings have to have the creativity to invent the system.
right.
So how do you feel like people have like a huge misunderstanding of artificial intelligence? What is artificial intelligence to you? And what is the human creativity that artificial intelligence can't touch yet?
So so that's actually a very good question. So for me, artificial intelligence is everything that we actually using now. As in, this machine that you're using to talk to me is running an AI. My phone that I use constantly is running an AI. And I'm not talking about the Echoes and the Google Assistants and Siris and all of that. I'm talking about the actual compute of what your machine does. And back in the 60s and 70s, or even in the 80s, the technology that we have with our algorithms now are so advanced that back then this would be considered as general AI. Like we're at a point where we actually have already AI. We already have artificial intelligence. It's just not general intelligence. So what I mean is that all the movies and science fiction that we've seen, they always show a computer being able to basically simulate a human, right?
Correct.
What they don't necessarily constrive of is that we why does a computer actually need to simulate a human? It doesn't. It can go ahead and achieve things far higher um than it would be kept capable of if it didn't simulate anything. If it tried to just do what its being is to do. Like
Mm.
it's the same way as how you can have a dog assuming that it's a human, but it doesn't mean that the dog is a human. It
Mm.
means that the dog is trying to simulate a human.
Mm.
And the piece here is that with an AI, with a general AI, you don't want the general AI to simulate a human because again, it would be limited by human constraints, meaning
Mm.
that it would have flaws the same way as we have flaws. It'll have limitations the same way we have limitations, and it'll have a lot of issues that we have with being able to remember or to acute what we said about 30 seconds ago.
Mm.
And these are pieces that we don't want from a new being, essentially, and being able to provide when it comes to compute. We want something that is able to learn a way that is different from us, but a way that can help us, that can actually communicatively help us.
Mm.
And I'm talking about both an AI and ourselves. So going back to it, right now, we don't have a general AI, and I don't believe we will get a general AI in our lifetimes. I don't believe we will get a general AI in a few generations, actually.
Mm.
The reason why is because we already have artificial intelligence. We just don't have it in a way that people feel is simulating humans.
They
But
don't
we
feel like
do.
it's Terminator enough or Skynet enough.
Exactly. We don't we're not building technology that way. What
Mm.
we've been building technology is being able to help us, being able to get to a point where it's ambient. And this falls into a very larger landscape where all technology has been moving, is ambient computing, is a way that the 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 way that you design your technology, the way that you design your software, it grows into its own way that it can actually help you. So whether that's earphones that are able to mute certain sounds while you're inside the subway, as
Mm.
in the subway itself, so that way you're able to not hurt your ears when you're taking the train, or
Mm.
whether that's being able to actually remember your voice when you actually speak to it and
Mm.
actually give you a response back, or being able to actually just save a specific icon inside your home screen when
Mm.
you're trying to actually go and use a software that you download. Yeah, that's actual AI. That's artificial intelligence. That's
Mm.
software that we've built in a way that is is able to be ambient enough that you're able to utilize it and automate pieces that you would normally wouldn't be able to do.
Mm.
So the artificial intelligence that we have now, I think is amazing. We
Mm.
have very powerful artificial intelligence. It's just not looked at as artificial intelligence because we're looking for the general AI. We're
So
not looking for the stuff that's actually helping us.
it's actually like interesting because when I go on Gmail and someone sends me a hey, can you make it on Tuesday? There's a smart compose now where
Right, right,
where,
right.
where it'll like give me options like I can click a button yes no, or when I type hi how are you and then it goes how are you doing and they just hit
Right.
tab. It's kind of insane how it's able to understand information and be able to predict which direction it wants to go. So it's quite astounding. So how important do you feel data information is going to be is the commodity of our lifetime?
So that's where we go back into what we were talking about before, where it's the machine learning algorithms,
Mm,
right? So the piece about the machine learning algorithm is, as I said before, is that the more data that you have, the better that they become,
mm,
because you have more data to be able to define the limitations of the constraints that you gave.
mm,
So it's able to give you a solution according to the specific data set that you have. Give
right.
a very large data set, it will be able to actually give you a better average to an answer that you want. Now, this is not necessarily true all the time. It doesn't mean that you can just go and take the entire planet's data set and drop it onto a machine learning algorithm and surprise you have an answer to everything. No, but it means that you have a way to start formulating answers to
Mm,
problems. So with our current design for these algorithms in machine learning, they're getting in a way that data is essentially the next oil field. It has been the next oil field for like the past decade. It's just people are starting to actually realize it now. So whether it's Facebook holding more than more than uh, uh, 2/3 of the planet's social network, or having a capacity where you know the search design of every human in the planet. We're getting to places where these data models are so large that they're able to start formulating answers to problems that we normally wouldn't think of answering.
mm,
So going back to it, um, uh, this plays into a very large role where what is AI, right?
right.
What is artificial intelligence? And I think that we already have AI. We have it everywhere. We have it in every single part. We have it inside our Google Smart actual definition predictions. We have it on our actual touch keyboards that we're using inside our phones. We have it in how we interact with our devices on every day, our lights, our everything. It's already there. But as we continue progressing further when it comes to our technology and when it comes to how we formulate our 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 structures and design for this software, data still plays the largest role, and it will
Mm,
continue playing the largest role. The better the data set, the better the data model, the better your company, the better that your product is.
wow. That's crazy. Wow. So mind mind blow moment because I feel like it's a lot to take in and giving like a mental exercise. You know, so like now like we have all the photos and searches. How when I do searches and then they're able to suggest what I want to buy, how valuable has that become?
That has to be one of the most valuable parts of software today. It's advertising. Every single major corporation that has become a corporation, or megacorp essentially, are all based on advertising. And there's a reason for that. It's that um, if you're able to adapt to how people interact with purchasing items, or just purchasing in general, you're able to find a way to give them an easier path to solutions. So let's say if you bought well, not even, let's not say you bought a pair of socks. Let's say you went on Twitter or whatever, and you just happened to actually go and look at a pair of socks that your friend had in a certain picture, right? And let's say Twitter was part of an ecosystem that gave its advertisement partners the capacity to actually scan that interaction with
Mm,
metadata, of course, not the actual picture itself. And that metadata then gives those advertisement partners like a little cue. It's like, oh, look, this person is thinking about socks. Okay, that's cool. So so this means that you might want to actually share more information on socks to this person. So as they continue going and using Twitter, they would see more and more socks inside their feed, inside their interactions, inside their search. And the reason is just simply for that small metadata interaction of that picture. And what this allows is a way to actually connect advertisement tighter to the consumer. It allows you to be able to go ahead and remove those advertisement models that required just waste of money. You're able to actually limit that by having the advertisement so close, having it so tightly connected to what you're doing. So when you're shopping in Amazon and you're looking for a product, but you don't buy anything, you use the
right.
search, you just use the search field, and then later on as you're going, you're starting to see more and more of this similar type of product, even though you didn't buy it. And
Right.
the point here is that it's trying to see what would be easier for you to actually get. What were you thinking about trying to solve? And that type of advertisement is what is the reason why data is so important, right?
Wow.
It's because of that connection. So the further that you get for your advertisement model to be closer to the consumer, the better that it is for you as a company that's selling a product. Because at the end of the day, you just want people to buy your product,
Right.
and you want people that buy your product that want your product. And
Mm,
what better way to get there than to have an advertisement model that connects people closer to them?
very true. So that being said, I have one final question for you because I know time constraints, we still have physical limitations. What are you most optimistic about in the next 2 years or 5 years in terms of technology and what the direction that it's going? Like, it can't
So
just be the next new cell phone.
no, I think um the most innovating change that we might have in the next couple of years is more adaptation to ambient computing, is moving away from using phones as the single point of your technology life, and moving closer to AR and mixed reality.
Mm,
Having a way to join what we have in software with what we have in the physical realm, and being able to actually interact with that, I think is actually doable in the next 5 years. And considering the moves on how many different companies have been sort of trying to achieve this secretly, or not so secretly anyway, I think we're definitely going to start seeing a lot of breakthroughs here, and we're going to start seeing a lot of technology that is going to be quite helpful for a lot of people.
wow, very cool. So I want to thank you again, Alex. This is absolute pleasure. I'm very grateful you decided to be on my show. I want to thank my YouTube audience, and I look forward to catching up with you when things like really it's like, hey, what happened? so so again, have a wonderful time, and I look forward to talking to you again.
Yes, this was great, man.